So welcome to all. Dear participants and presenters, there is an announcement from the organizing committee desk. Day 2, 1 and 2 paper presentation details and schedule are updated in the website, and it's sent to your mail also. Check your mail and website. Participants, please join in the given link. Today there are 6 sessions. After the keynote speech, the single window or screen will be divided into or break out into 6 windows. In our system or mobile shows a new icon of 4 boxes. Click the icon. It shows session 1, 2, 3, 4, 5, 6, and you presenters can join your respective session. Participants or listener can join any session as you wish. If you face any difficulties, then don't worry, we are here to help you. Ping your difficulties in the chat box with the name and ID, paper ID, or call this number 9840858539, which I have sent your email also. And presentation is mandatory. The chairperson and moderators' comments and grade or rank will be taken into the account of the reviewer of Springer Journal comments. A pleasant news to you from the conveners. A good presenter will be evaluating from our presentation. He or she may be honored in the next Fatter Academy of India conference. Thank you.
I'm sorry, Lila, can you start with Professor Zinaida?
So we'll hand over the session to the chairperson.
Yeah.
Maybe while my colleagues will mute.
Zinaida ma'am, are you hear a voice?
Professor Zinaida, are you hearing the voice, please? Professor Zinaida. Professor Nina.
Okay, let me say a few words.
Please. Where is the Lilia?
In the link?
Lila?
Professor Zinaida is connected to us.
Yes. She is connected, but she is, I think, muted or unmuted. Please check.
It is unmuted, sir. It is unmuted.
She is unmuted.
Lila is unmuted.
So ask Leela to initiate the process with Professor Zinaida is help.
Lila is unmuted.
Leela is unmuted.
Yeah, I see.
Okay, please ask Lilia. Dr. Ramutha, please unmute Lilia.
I think we can do it ourselves. My microphone works. I think not the host is the problem. Please, Professor, try to unmute yourself.
Yes, ma'am. Yes, ma'am. You're right.
Lilia, are you able to hear us?
Please try to.
So unmute your mic. Unmute your mic and ask Zinaida, Professor Zinaida, to initiate the process. So may I request Professor Nina?
Yes.
So in the meantime, let me introduce you, because Lilia, are you going to initiate the process or let me initiate the process? Professor Nina, you may ask Professor Zinaida whether she is listening, otherwise let us
Can you start? You have some.
So we are you as a co-host. So you have to unmute yourself.
Okay. Well, my colleagues have so technical problems with muting their.
Professor Liliana Kuran, please unmute yourself.
No, Liliana Guran, no, this is Lilia Kukraska and Professor Zanaida. Professor Zanaida, are you here? There's a lot of time. Yes, he's here. Ask to unmute. I think she has some issue. So, Professor Nina,
Yeah.
I would like to introduce you and please start because 20 minutes have been lost.
Okay.
And Lilia is, I think I'm not able to understand what she is doing. She should introduce you, otherwise I am going to introduce. Lilia, would you like to introduce Professor Nina? No. Professor Nina is a professor at the Uzod National University, Uzod, and a very good researcher, especially in the field of economical and big data analytics. She is associated with FAI as a FAI Executive Council member, actively involved in a lot of academic activities, providing her essential support, always ready to support us whenever we have asked to come forward. She was, and during the last month, Professor Nina was one of the convener of the IUB-GMS 2020 that was organized during the November 20 to 22. Under the leadership of Professor Nina, that conference was organized. And in this moment, I think I have a lot of time has been wasted in the technicalities and other issues. So may I request Professor Nina, please start your talk and enlighten each and everyone.
Okay, thank you. Thank you very much for such a nice introduction, dear Professor Pantai. And I would like to, on behalf of my colleagues, Ukrainian colleagues, to say sorry for such technical problems with the muting. And it's really a great pleasure for me to welcome you all at the second day of the 22nd FAI International Conference, Mathematical Computational Intelligence and Engineering Approaches to Healthcare, Business and Tourism Analytics 2020. The theme of the conference is really very important and urgent for nowadays. We live in a very dynamic world, and only those can reach success and can be stable at these turbulent surroundings who use innovative approaches based on the combination of mathematical, digital, and economic effectiveness aspects, along with principle of sustainable development. Actually, this conference is a platform to share ideas in the sphere of different knowledges. I must say that FAI, Father Academy of India, monthly try to provide an opportunity to meet together scientists and experts from different countries and different fields. Personally, really, I joined to these events organized by FAI in May of the outgoing year. Thanks to Professor Pankaj Srivastava, the General Secretary of FAI, I was invited to deliver a speech at that conference. And then I got the honorable offer to become a member of the Executive Council of FAI, for what I express my sincere and cordial gratitude to the General Secretary of FAI, Professor Pankaj Srivastava, to the President of FAI, Professor Bisht, to our colleagues, Professor Sisitan, Professor Raghuraman, and to all members of the Father Academy of India. I deeply appreciate our coordination and cooperation and collaboration within this academy. According to my observation, the FAI is constantly expanding contacts around the world, generating new ideas, for new conferences and motivating scientists to new investigations. So to be short today, I'd like to wish everyone to enjoy perception of new ideas during this conference, to join our future events, and good luck for today. Thank you very much.
Thanks, Professor Nina. Thanks. So, dear Dr. Amutha, please take the note and invite Professor Vichian, who is waiting. Doctor.
Yes, sir.
Yes. Please invite Professor Vichian. He is waiting.
Yeah.
And
Yes,
Professor PG Patil.
So thank you, Professor Nina. It's a mind-blowing session. And next, let me welcome Dr. PG Patil to inviting the resource person, Professor Vichian Lahakosel, Department of Mathematics, Kasetat University, Bangkok, Thailand. Let me hand over the session to Dr. PG Patil, Professor, Department of Mathematics, Karnataka University, Dharwad, Karnataka, India.
Good afternoon to everybody. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Sir, welcome to the second session of this FAI International Conference. And I thanks the organizer for giving an opportunity for me to chairing this session. Yes, Professor Vichian is a senior most professor in the Department of Mathematics at Krestu University, Thailand. Professor specialization is number theory and classical analysis. And he completed his PhD from the Illinois University at USA, MSc from the University of Adelaide, Australia, and BSc from honors from James Cook University of North Queensland, Australia. He is very senior professor in mathematics. I request Professor Vichian, I will hand over to the Professor Vichian to start the session, lecture.
Please unmute, sir.
Unmute, sir, please.
Professor Vichian, please unmute.
Unmute.
Professor Vichian, please unmute yourself.
Okay, can you all hear me?
Yes.
Okay.
Yes,
Good afternoon from Bangkok. I am here to say something number theoretic today. So let me just start because I don't have much time.
Yeah.
If you allow me, I should have some share screening. It's not allowed.
Open the PPT file, sir. Open the PPT file and then upload. Quickly, it will come on the screen.
I'm not allowed to share the screen.
Huh?
The host is not allowing me to share the screen.
Host is not allowing.
Yeah.
Host,
Sir?
why are you not allowing to upload the screen?
No, sir.
Please allow. Please allow.
Okay, sir.
Please
Okay,
allow.
sir. Now professor can share the screen, sir.
Okay.
Okay, can you all see?
Yes.
Okay, so I'm going to talk today about some number theoretic. This is a continuation of my work from last year in Jabalpur. You remember last year in Jabalpur, I gave a talk about arithmetic functions, convolution, and finite Fourier series. And after coming back from India, I gave this problem to Pusadi Her name is on the screen now. She's my PhD student who has just passed her final exam. She's now a full PhD and now finding a job somewhere in Thailand. So this is what we have come up with, the work that I'm going to report to you today. So my talk will concentrate on 3 sections. The first will be introduction, so everyone should get acquainted with what I'm going to talk about. And second will be the ideas we generalize the unitary convolution and its relation to Ramanujan sums. And thirdly, I'll talk about some applications. So we start with the introduction. Well, we know from school maybe, and in the first few years of university, that an arithmetic function is a complex value function whose domain is a set of positive integers. And usually we use the script A to denote the set of arithmetic functions. The most well-known probably is the Euler phi function, which counts the number of positive integers not exceeding n and relatively prime to n. And written in the summation form, it looks like what we have on the screen. And the second most well-known, I hope, is the Mobius function, which is defined to be 1 if n is 1, and equals to 1 minus 1 to the s if n is a product of s distinct primes, and 0 otherwise. So these are well known from our school days. And in the setting of arithmetic functions, usually we define multiplication as Dirichlet convolution. It comes from mostly from the application to other number theoretic problems, where we define f star g to be sigma d over n of fd times g n over d. But what we are dealing with more or less today is FUG, which is F unitary convoluted with G, defined to be sigma F of D G N over D, where the summation is taken over D, which is a unitary divisor of N, which means that D is a divisor of N whose greatest common divisor with N over D is equal to 1. Don't be surprised at why we are so fantasy about this, because it comes as application that this is a sum. It crops up naturally in the study of analytic numbers, or you want to count some special numbers, you come up with all these operations. The thing to keep in mind is that the ring A with ordinary addition and Dirichlet convolution is an integral domain. On the other hand, if you replace the Dirichlet convolution by the unitary convolution, you get a ring, commutative indeed, but it is a ring with 0 divisors. So this gives you a very good example or a good system to play with if you are working with ring with 0 divisors. And luckily, the identity function for both convolutions is the function in defined to be 1 if n is 1 and 0 otherwise. And another concept we need to know is that a function is said to be multiplicative if fm times n is fm times fn whenever mn is relatively prime. And we usually denote the set of multiplicative functions by script m. Note that both the Euler's phi function and the Mobius function are multiplicative. And another fact which is well known is that both the Dirichlet and unitary convolutions of 2 multiplicative functions are also multiplicative. Now, the classical Ramanujan sum is defined as shown on the screen. This is a sum over one complete set of residues mod k, which is m runs mod k, where m and k are relatively prime, and exponential sum like so. This is one of the definitions I take. And in order to define the unitary analog of this Ramanujan sum, Cohen in 1960 defined it, replacing the usual GCD by the unitary GCD, which is the maximal divisor of M, which is a unitary divisor of K. It looks fanciful, but it works out that it's very useful indeed. And Cohen was one of the first investigators of these unitary analogs of so many things in number theory, but we are concentrating on analog of Ramanujan sums and some other related things. And in the 60s, Cohen defined other related functions, for example, unitary torsion, unitary Mobius function like so, showing on the screen now. And he also showed that the unitary Euler's Y function counts the number integer m, which is unitary relatively prime to mk relatively prime, which is written in the formula like that. And of course, comparing to this, the classical case of phi n can be written as a convolution of two functions, mu d times n over d. Cohen also proved that mu by n, which is the unitary analog of the Mobius function, satisfies very similar things. Mu by n, we have seen that before, is minus 1 to the s. Now it becomes minus 1 to the omega n in the unitary case. And in the case of phi function, you look at the expression, they look very much the same. The only difference is the summation is over the unitary divisors. Let me mention in passing that the concept of unitary divisors was first originated in the 30s by an Indian mathematician, Yaswamy, I think. He wrote a paper in the transaction of the American Mathematical Society, very longish paper, and he called at that time the unitary divisors as block divisors. So I'm going back to India by Yaswamy. And in another direction, if we define a generalized convolution of two functions f and g by s, f, and g, written like so, in 1982, Johnson defined a generalized unitary convolution of this as s star f of g, replacing the GCD by unitary GCD and division by unitary division. The first SFG over here is, you might be surprised why we consider this, because this is one form of the generalization of Ramanujan sum. So it sort of leads us to consider this rather than just Ramanujan sum. And Johnson proved that SFG is multiplicative in the second coordinate and satisfies certain things when you specify functions f and g. Our objective here is to go further like what I did last year in Jabalpur by further generalizing the unitary convolution and unitary Ramanujan sum, and having give generalization definitions and so on, then we should look at their properties, and last but not least, we should look at the applications. Otherwise, all these investigations will be just nothing if there are no applications. Well, let's go to general. This is to remind that in 2013, there is another guy named Van der Kamp referred the same thing as what I did before as unitary convolution, but instead of writing SFG, he wrote FUAG as very much like SFG, only that you fix the first coordinate to be a fixed integer A, and all other things are the same. And so all these identities and concepts are cropping up now and again. A lot of people later on keep trying to prove certain things that have already been proved before. One of the things that I put myself down into this work because I want to combine them into one setting of unitary and generalized convolution, so we don't have to prove this again and again in the future. So that's one of my aims at that time, about many years ago. Now, having defined the unitary convolution, we first established the basic properties like commutativity and associativity and multiplicative property as in theorem 1. I'll go through this quickly because we are running out of time somehow. And this is one of the milestones in the setting of arithmetic functions. Is a so-called Mobius inversion formula. In this case of unitary setting, we also have this, and it looks like so. The condition that we need to have this inversion formula is the function h has to have an inverse, which means that h at 1 is non-zero. This is the inverse with respect to unitary convolution. And also similar things, similar properties. Just keep in mind that we have all these properties settled. I'll just go through this quickly. And its connection with some other number theoretic functions, for example, divisors functions. And this is my generalized unitary Ramanujan sum. Instead of using the unitary Mobius, now we use mu subscript alpha. The case when alpha is equal to 1 is the usual case of unitary Ramanujan sum, but it also works for any mu alpha where alpha is a complex number. Mu alpha is the function which I have been treating for many years now, with a lot of papers written about them. And you can probably search your Google for this. This mu alpha is called the Fourier-Mobius functions. I usually call because I attributed it to Fourier, in the French mathematician who invented it in probably 1940 something. I'm not so sure now. And with this generalized Ramanujan sum, all the existing properties when alpha is equal to 1, most of them, not all, but most of them carry over. If you substitute alpha for 1, you get the usual unitary Ramanujan sums. And also the other properties put down as in corollary 5. Now let's look at applications. This is the thing I want to impress you most. For example, who can guess that this is an identity? This is along the line of Ramanujan. Ramanujan wrote tons and tons of properties like this, or identities like this. For example, the first identity is if you sum over a residue class mod k of the GCD mk cos 2 pi m over k, this becomes the Mobius, the Euler's function evaluated at k. In the classical case, this left-hand side is just ordinary greatest common divisor of m over k. This is so beautiful that you can hardly know that there is such a thing, and it's not easy to prove in the even in the classical case. But if you put everything down into this setting, it drops out not too difficult. And the second and third identities are also. If you just take some example to get some numerical evidences, it looks like this. Another example. Continue on. Earlier on, I put this just M OK without any F in the last assertion of the corollary, but it also works if F is just any arithmetic function, as long as it's multiplicative. In the case when it's multiplicative, we can write this out into a product form. It also works when the GCD is replaced by a log of another arithmetic function defined with the GCD. In this case, it's unitary GCD, of course, and so on. The von Mancourt function, which occurs naturally in the study of prime number theorem, has also